last team, Minnesota. You guys here?
Yep, we're here.
Okay. All right, let me swap over to the paperwork I have for you guys and take a quick, okay, 30K SRAD. Okay. So my first question is, so what drove your decisions in terms of materials for the nose cone and the airframe itself? The airframe
Yeah,
tubing.
so as you can see from our report, we do utilize both fiberglass and carbon fiber in the construction for that upper airframe and nose cone and different body tube sections. So we use the fiberglass for where we need to have that radio frequency transmission to happen. So we have electronic systems within the nose cone and within that electronics bay within the middle of the rocket there.
Mm-hmm.
And we do use the carbon fiber as well. There was actually a senior design project this year on campus that provided us free of charge carbon fiber. So we were very grateful for that, and we used that. And our team as a whole is always trying to expand our knowledge on all the different manufacturing techniques. So that is carbon fiber and fiberglass. We utilize both pre-impregnated carbon fiber and wet layup practices for both those.
Yeah. Lucky you guys with the free carbon fiber.
We're very fortunate. We're very thankful, yeah.
Yeah, okay. And then, so, fins. Where did I missed the section where you talk about your fins.
I can talk about them quick.
Yeah, you want to, go ahead and talk about your fins.
Yep, so we have our motor case and motor tube all integrated into one, and being that it's aluminum, because it needs to be aluminum for that motor casing, the easiest way to mount fins onto that we've found is just hardware. So we have aluminum 1/4-inch fins, and mounted to that is the aluminum mounting brackets that are bolted directly into that fin, or that motor tube. And having holes in a pressure vessel, that does bring up concerns, I know, but we do that tested with FEA, as well as just multiple tests over the year when we're doing our engine tests. So
okay, so you did. So those tests were after all of those holes were drilled and you had the fins mounted. Yeah. Okay.
It'd be scary not to do that.
Yeah. Doing it the other way would definitely raise several eyebrows.
Raise some flags, yeah.
Yeah. Okay. So you've got a primary stratologger and then a redundant Marza 33 for your avionics. I see here, and you're using lithium-ion batteries. So can you talk about the battery system that you're using there?
Yeah, so we're using 9-volt batteries for the stratologger and the Marza itself. That's what they're nominally ran at. The lipos are mainly for the Kate system, and then for our own custom system called Days.
Okay, so you are using 9-volt alkalines for your deployment systems.
Just a standard 9-volt alkaline.
Okay. So in that case, now I get to ask all of my alkaline 9-volt questions.
Oh boy.
So, have you guys done? So what have you guys done in terms of testing on those batteries? Because I know that certain 9 volts are good and are fine, but especially for high G flight, like I expect you guys are getting going up to 30K. some of them where they only have like press fit cells, those can be really problematic at high accelerations, and with lots of vibrations, you can actually lose contact in there. So what have you guys done in terms of any sort of disassembly on those batteries to make sure that the ones that you're using will hold up under flight forces?
So I didn't actually know that was a possible failure, to be honest, of the splitting of the cells. So as far as I know, we haven't really done that much testing on it per se.
I'd also like to add, though, being that we do manufacture our own motors, we can tailor that, and we do actually manufacture very slow burning motors. So being that we are going to 30K, we do take a while to get there. We're only reaching 1.5 Gs compared to other teams. That's a very short burns, high acceleration rockets reaching 3-4 Gs. So under these conditions, I feel like that 9-volt battery, welded cell, press fit cell is less of a concern, but it's still a concern that we want to take forward. And maybe move on to just using lipos, like you've been saying.
I mean, lipos have their own problems with over discharge and overcharge and shorting out and causing fires, but but it's the issue with the press fit cells is actually, it's something that I've seen happen, and I mean, I wouldn't be surprised if I think it was the West Virginia team earlier who were talking about having some failures with their electronics, losing power, and I mean, I wouldn't be surprised if that was a factor in that as well. So yeah, it might be worth sacrificing a battery to, at the very least, sacrificing a battery to the disassembly machine to see what you guys are working with and see if you guys need to make any changes there. And then you're using screw switches, according to this. Is that correct?
Correct.
Yeah, screw switches to start the Mars and the Stratologger.
Yeah, awesome. Love screw switches. And then, okay, we've got drift calculations. Yeah, so you're using, so for your GPS tracking systems, I see 3 different things mentioned here. I see Kate, I see the featherweight GPS, and I see your own experimental custom PCB system. So which ones are you using?
So the primary recovery system is the Kate module. That's a commercial off-the-shelf system.
Yeah.
It's the Kate 1.0. So that's what we primarily use for tracking. The featherweight is APRS certified, so that's for competition rules, obviously, right?
Okay. Yep.
And then we have our own experimental system, which we've been working with in the past, just to see if we can kind of mimic the sort of, Kate level of
functionality,
right, and functionality in a more cheaper, and more customizable fashion that we can, tailor to our own system.
Yeah, that's that's certainly an admirable goal, and
it's a lot to live up to, which is the tough part. But I mean, we're working on it.
Yeah, that Kate system is really something else. To have the disposable income to spend on one of those. So are all 3 of those systems in the nose cone, or
no? So our Kate module is the only thing in the nose cone, and then that's operating off 900 megahertz. I don't know the specific subfrequency of that, but it's the commercial one.
Yeah.
And then inside of the eBay is where we have the Strato, the Marza, and what's known as the Dave system.
And then the so Dave, and then the featherweight, is that also in the avionics bay?
Yeah.
Okay. Okay. Yep. So testing wise for all of those systems, so first off, I guess, power consumption and battery life, what are you guys looking at in terms of like power on time sitting on the pad?
Yeah, so here, let me pull my calculations again. So if I believe with our custom system, if it goes into the low power mode and it uses acceleration interrupts to wake it up, that had a battery life, if the GPS is locked, of about 10 hours. If it's not locked, it's like 20 some hours. Kate has about 10 hours if it's fully charged. The Strato on the 9 volts, because it has a low power, mode that it defaults to. I believe it was 6 hours. And then
I think it's longer than that.
Is it something like that? It was something around 6 hours, I think. We might have had a bad battery when we tested it though.
Yeah.
We tested it like 2 years ago.
Yeah. Because I remember doing some testing on a Stratologger with a 9-volt, and basically it would last for days.
Okay.
Yeah,
we
so
probably just had a dead battery then. We might have grabbed the wrong one. And then Marza, I don't think we have any calculations for, but I'd assume it's relatively more than 5 hours. So
yeah. And then for your various different downlink systems, what have you guys done in terms of range testing to confirm that you have the range you need for your flights to 30K?
So we actually were able to do, for our custom system, we had our old president, Eric, did some testing with the LoRa modules, the transceivers, over 900 megahertz, and we got it to be, what was it? It was 4 miles, I think is what it was, across the lake. He went and visited a lake up in Minnesota. And then you had the transmitter on one side and the receiver on the other side. So that's for that system. Kate, we haven't done any testing with because it's a COTS system.
Yeah.
And then APRS we didn't really test, as far as I know.
Okay. Yeah, which is also a COTS system. So there's test data out there for that one. Yeah. A lake in Minnesota.
Yeah.
Very descriptive.
I don't remember exactly. I think it was his cabin or something. He just grabbed the system. He's like, I'm gonna go test this, and then went and did it. So. Yeah,
that makes sense. Yeah. I mean, 4 miles. I mean, you might want to see about like what you were getting in terms of gains and signal strengths at that range, just to make sure that up to the roughly 6 miles that you'll be okay. Okay, let's see. We've got a bunch of pressure strength simulations, and you did buckling simulations. Nice. Yeah. So
our first year at IREC, we came in with a 20-foot rocket, so doing buckling simulations is fairly important.
Oh yeah, with the long skinny things, they're gonna buckle.
Oh,
yes. Yeah. Okay. What is it with everyone and using 632 nylon shear pins?
It's McMaster car. It's cheap, and we just designed the black powder charges to work with that system. So that's what it comes down to.
Yeah, it seems like you probably could get away with something smaller, but I mean, yeah, if you've done the calculation for the air pressure, pressure difference, that would, yep, you have done that, and yeah, it makes sense to have the number of bolts that you do and the size for 30K. Okay. Yeah, so I guess the only other question that I have is for your testing of, so what testing have you done on your motor, and have you done, I guess first question is, have you done any flight testing?
We've done flight testing the past not last year, but the 2 years prior to that at actual IREC, but not this year with just flight testing beforehand. There's a lot of money that goes into manufacturing our own motors to reach 30,000 feet of flight testing. Exactly.
Yeah. Okay. Yeah. So you have done previous flight testing. Nice pre-flight checklist. And so I guess, what would you say, I guess I'll go with the closing question. What would you say would be the biggest challenge that you guys had this year, aside from just like I guess
COVID.
Yeah, aside from
COVID,
aside from working with COVID, because that's what everyone's been dealing with. So I guess aside from that, what's something that you guys have found difficulty to have found difficulty with, and what have you guys done to deal with that?
I guess I'll let someone else take this. Yeah.
Yeah, sure, I can take it. So this year, I guess our club is around, I would say, 24 to 25 active members. And this year, unfortunately, half those are seniors that are actually leaving. And so with that, we're losing a lot of just this big knowledge base. And so this year, myself and a bunch of the other sophomores and juniors that are also on the team have kind of made an effort to try and learn just as much as possible, as well as just the team overall working on our documentation of at least each committee basis. So like, I guess I'll use recovery for an example. We have a really great recovery notebook. Shout out to Caitlin, I guess, on that one. But it covers, and it just gives a really good introduction and kind of logical reasoning behind all of the calculations that we've done for the recovery systems, like our parachutes, as well as the manufacturing methods. Oh,
you're cutting out there a bit.
Yeah, he's cutting out a bit.
Yeah. But I think I got the gist of it.
So basically, the knowledge transfer is a huge one, and maybe more on a technical side of things. This was the first year that we dove really deep into composites. We've done composite in the nose cone with the help with a mentor who tailored the way and initially made it easier for us to do so. But moving forward, we want to do all these things more independently. And there's a lot of challenges with that. We had to make our own composite curing oven for some of our composites we do, and different techniques with the material. Given the materials we were given, working with those to make it work. We found some challenges within that we had to overcome, and overall we manufactured good tubes, I think, in the end. So we're looking forward to using them next year as well, or making new ones as well.
Yeah. Okay. That sounds good. Thank you guys for waiting until the very end. An extra hour and 15 minutes beyond the planned time, but I'm glad we were able to get everyone in eventually.
All worked out.
Yeah, all worked out in the end. Yeah. So unless you guys have anything else, I think I'm done, and I think we can probably call it here.
All right. Yeah, I just want to say thank you to you and everyone at IRAC and Spaceport for this opportunity, and we're looking forward to come back in person next year. So.
Oh yeah, looking forward to get out there again.
Oh yes.
Yeah. All right. Take care.
Awesome. Thank you.
Thank you.
Thank you.